Hello, everyone. How are you guys doing today? Good. It's so weird that yesterday it was rainy, cloudy, everything, but I had a full class. And today is so sunny, so cool, and everything. But I see empty class. Half of the class is empty. People are so weird. Okay, so how are you guys doing today? Good. So as a reminder, our exam 1 will be exactly 1 week from today. It will be based on chapter 3 and section 4.123. We are going to skip 4.5 for our exam 2. Any question before we start? Nick. So Monday, midnight, you're going to have homework 3.5, 3.6, and quiz based on 3.5 and 3.6. 2 quiz, 2 homework. Any other question? On my laptop, the quizzes are not already. Because I didn't change the time, I'm going to change the time today. So that would be that the quizzes have been defined yet, right? So next Monday. They all are open. So I'm going to close them. I'm going to put the deadline Monday midnight for 3.5 and 3.6. I was waiting to see how much you can finish this week so that I can assign the homework over the weekend. Any other question? Nah. So in our last class, we did evaluating functions, and he said all you have to do is replace x with the number they give you and then simplify. Instead of keeping your fraction, make it bigger, you can simplify the fraction. It will make things easier. For example, the last one here, instead of working with fraction, if you simplify your fraction, when you see the fractions cancel out, you get a whole number. Same thing here. If you cancel the fraction, it becomes a whole number. And here also you get a whole number. So always try to simplify the fraction instead of multiplying the top. Today we are going to do one more example. And here we have a different types of function. It's called absolute value function. Absolute value function is a special types of function. What it does is, I have only half here. What it does is, if we input any number into the absolute value function, it always spits out something positive. For example, if you write absolute value of, let's say, -2, it will spit out +2. If you put absolute value of, let's say, 3, it will give you the answer 3. Okay, why? Because absolute value tells us the distance between 0 and that number, it's the number inside the machine. So -2, it's like how many steps we have from 0 to -2. We have only 2 steps. So that's why absolute value of -2 means it's a +2. Means the distance from 0 to that number is 2 units. And this is also true. 0 from 3, we have 3 units distance, the answer is 3. So when you evaluate absolute value function, it's just like the normal function. We substitute x with the given number and then simplify. So we have f of x is absolute value of 2x minus 1. And they want us to replace x with 3 numbers and tell them what numbers we get back for the y. So the first one is f of -2. It means we replace, so this is the absolute value. We replace that with -2. And then what do we have? Inside the absolute value, what do we get? What is 2 times -2? -4 minus 1. And what is -4 minus 1? -5. So what is absolute value of -5? 5. You cannot leave your answer with the absolute value. You always have to write the next step. If you don't, then you're not gonna get points, full points. You get half credit deducted. Okay. Now try the other two. What is f of 1/2 and f of 7? Hmm? And then the last step, integrate. Now, in the next step, oh, okay, that was easy, right? You guys did great. What is half of 2? 1, right? The 2 cancel out, you get 1. Or logically, half of 2 is 1. So we have 1 minus 1 what is absolute value of 0, which is simply 0. The other one is the easiest one. 2 times 7 is 14. And what is 14 minus 1? 13. And then absolute value of 13 is 13. You actually have to keep writing the absolute value until the last step. Okay? Don't just take it out here and tell me the answer is 13. It's wrong. In the exam, you should. Otherwise, how do you know which one is the last answer? So here we are saying that when x is 1/2, our y value is 0. That's fine. Absolute value of 0 is 0. Because absolute value tells us the distance from 0 to the number inside the absolute value. So what is the distance from 0 to 0? 0. Doesn't have any distance. Okay, now new concept, domain and range. I mean, it's not new. We already know domain and range, right? Domain represent what? X. And range represent Y. So if you're dealing with a graph and you're finding the domain, all you have to do is observe what is the smallest x value to the largest x value you use in your function. Put them together in a parenthesis or a bracket, depending on your number, and then you have your interval of domain. Similarly, range, in order to see the range, you observe your y-axis. From which smallest y value to largest y value you have in your graph, that's the range. Okay. Ready? So arrow means the graph is going on forever. If the graph is going on forever, what is the leftmost point we have in the graph? Negative infinity. See, every x value we see in the graph, so the more the graph is going downward, we're using all these x values. The smallest x value will be the smallest number in the number line, negative infinity. So domain starts from negative infinity. And if you look at the right side of the graph is going on forever and ever and ever. So what is the highest x value we are using in the graph? Infinity, which is the biggest number we have in the interval. And that's it. That's all you have to do. Observe your graph and see what is the smallest x value used in the graph and what's the largest x value used in the graph. And between them, did you use every x value? Any question on domain? Is anybody who doesn't see what's going on here? Tell me what's wrong. Domain is x values. So did you use this x value in the graph? We did, right? Did you use this x value? We did. Did you use this x value? The graph is going on forever, so definitely somewhere here we have this x value. And the largest x value is somewhere here. If the line keeps going on forever and ever, are you going to use this x value here? No. So what's the smallest x value we have? Negative, which is the left side. Same concept here. Are you using this x value? How about this x value? And the line is keep going on forever. So are you going to use this x value in the line? Somewhere here. So the largest number is here. So are you going to use this x value? The smallest x value to the largest x value is our domain. How about range? Range is the y. So what is the smallest y value you see in this function? Remember, the line is going on forever on the downside. So did we use this y value into the function? It's here, right? We use that. How about this y value? Did we use this y value into the function? Yes, we do. How about this y value? We have it here, right? And the line is going on forever and ever and ever. So what is the smallest y value we have on the downside? Huh? The more the numbers are going down. So with negative 10, what comes after negative 10? 11, negative 12, negative 13. And then if you keep going on and on and on forever, what would be the smallest number you have on the negative side? Negative infinity. So we have a number down there which never ends, which is negative infinity. And we are using every number from the y value into the function. So what is the smallest y value we can have in our function? Negative infinity. That's the range. What's the smallest y value you have in your function? Until what's the largest y value you have into the function? So if the line is going on forever, what is happening to the y values? Are we using all the y values we have? So what will be the largest y value we have in our graph? Infinity. The line is going on forever. We don't know how big it is. So we have negative infinity to positive infinity. You just observe y value and ask yourself, am I using this y value to the function? And then if you have a point, yes, we are. If you don't, then you don't. If it's just a line, it means going on forever. How do you know it stopped if you have a scenario something like this? Let me give you a scenario. Let's say you have a graph. This is our x, this is our y, and let's say our graph is something like this. And let's say this is -1, -2, -3, -4. And let's say this is +10. And let's say this is the x value 5. And this is the x value -7. Okay, something like that. Now this graph is not going on forever. How do you know? We stopped here and stopped there. It's a closed circle. Okay. So in this graph, what is the smallest x value you see in the graph? -7, right? -7 is here. After that, take the portion of the graph. So our graph starts from the x value, -7. So domain starts from -7. And then we are using every single x value into our function. See, all those x values, every x value is here, this one is here, this one is here, this one is here, this one is here, until what is the largest x value you see? 5. So this graph is a portion of the big graph. It runs only from -7 to 5. So domain is only x. Okay, now we have a problem. When our x is -7, do we have a point for y there? Our x is -7, so y value is here. Do you have a y value there? No, right? Because they have open circle. Open circle means no y value is there. Let me write, this is -5. So for x equals -7, it's supposed to have a y value, but we don't have a y value. Since you don't have a y value, see, they opened it. Since it's a no y value, so for -7, we have to put a parenthesis. Parenthesis means the number next to the parenthesis doesn't have a valid y value. Okay, so we cannot include -7 in our domain. We have all the fractions, tiny bit, decimal, everything up to -7. But when x is exactly -7, we don't have any y value. This is what it means. Now look at 5. When our x is 5, do we have a y value there? We do, because it's a closed circle. Closed circle means y value exists. Open circle means y value doesn't exist. So let me write this down actually for you. No y value. Have y value. So close means we have an y value. Open means there is no y value. There's a gap. There's nothing there. So since for 5, x equals 5, we have a y value. So our domain includes the 5. So when x is 5, we have a y value. This is what it means. But when x is -7, we don't have a y value. Meaning for x equals -7, no y value exists. And bracket means when x is 5, y does exist. Now we found our domain. Now let's look at the range. Range is the y values. So in this graph, what is the smallest y value you see? 10. 10 is biggest y value. So biggest y value is 10. But everything has to start from smallest to the biggest. Like when you're born, we are small, right? And then eventually you grow up. You cannot just grow up and then become smaller, right? So it is like that, our interval. You have to start from the smallest one and then go to the largest one. Negative what? -3 is here. We do have a y value. But how about this point? Doesn't this point has a y value? And how about this point? Here. Doesn't this point have a y value here supposed to have? So what is the smallest y value supposed to have here? Here. This is -5. My graph is a little bit messy. -5. So what is the smallest y value you have in the graph? -5. So smallest y is -5, largest y is 10. But see, when y is -5, we have a gap. Gap means there is no y. We're supposed to have one, but there is not. There is none. So we indicate that using a parenthesis. That when our y is -5, there is a gap at that point. So y equals -5. We can go up to -5, but you have to stop exactly -5. Because we don't know what is the closest number to the -5. Is it -4.99999999999? What is the smallest number that is? What is the closest number to -5? We don't know. That's why we say go up to -5, but remember at exactly -5, you're not going to find anything. That's because we have a hole there. Okay, and we know the largest y value is 10. So when y is 10, do you have a valid y value there? We do because it's close. Close means, yeah, we have a number there. So since we have a number, we represent that with a bracket. Bracket means the number next to that does exist, and parenthesis means the number next to that doesn't exist in the graph. Okay? Any question? No. So I did 2 examples with you. One with continuous, it's growing forever. So when it grows forever, we have negative infinity to positive infinity. But when you only have a portion, we have to look at the numbers. Do the number X? Do we have the number in the graph, or we don't have the number in the graph? If we don't, we represent by parentheses. We do have a number, then we represent it by close brackets. Now you try. We have 3 more. So try this one first, and then I'm going to show you 2 more. Let me take that in this. Today is what? 7. Brianna Almonte. She's absent. Christina. Catherine. Jolene. Govan. Madison Field. Eric. Abraham. Stephanie. Leandra. Robert here. Katie here. Kimelcia here. Maria. Mariana. Sandis. Oh, he changes it. Michaela. Madison Orlando. Angie. Mazabin here. Melvelis. Melvelis Ramos. Giselle. Yeah. Mohammed. Here. Tahsin. Absent. Gavin. Brianna, Texas. Brianna Almonte, right? Carla. Carla. No. Yvette. Nick. Here. Danielle. Hassan. Hassan, you already have your 3 absences. So let me actually tell you who already has 3 absences. Brianna Almonte, 3 absences. Abraham, you already have 2 absences. Melvelis, 4 absences. Gavin, you already missed your 3 classes. And Hassan, 3 classes. So I said 4 absences will be excused. After that, no matter what you tell me, I'll count every absence. Okay? And your attendance will be counted towards your grade, towards your quiz. So quiz and attendance together is 10%. So why is it absence? Use your absences wisely. Okay? Are you guys done with this example? Okay, let's see. Domain. And let me write range here. Who would like to try domain? Bless you. Perfect. Negative infinity to positive infinity, because both on the left and on the right, the graph is growing forever. It's not stopping anywhere. So it's everything. Who would like to try range medicine? Positive infinity is the largest one, but remember, when you born, it doesn't grow up, right? So you have to give me the smallest number first. What is the smallest y value you have in your graph? 8. 8 is here. Is this the smallest y value? 0 is here. Do you have any graphs when y is 0? Isn't it 3? See? This is the smallest y value we have. So it starts from 3. And then you grow up to infinity. So when our y is 3, do we have an open circle or closed circle? So what are we supposed to have for 3? Parentheses or bracket? Bracket. Only when we have whole, we use parentheses. Except for whole, if you don't have a closed circle or you have nothing, it's continuous, it's always bracket. So whether you have a closed circle or whether you have some type of line, it's always bracket. Okay. Only whole means parentheses, otherwise it's bracket always. And infinity is a symbol. That's it, always have a parenthesis, not a number, symbol. So look, whole and parentheses, they look similar, right? We just have nothing on the top, nothing on the bottom. So remember this way. When you put parentheses, when if the parentheses becomes a whole. Okay? Any question? Like any line, for example, if you have only V, see here they highlighted the dot clearly, but even if you don't have a highlighted dot, when you don't have a hole, it's always brackets. So it means a line, like any type of line. See here you have a line. Mm-hmm. Why is there not a bracket? Infinity always gets parentheses because we don't know what is infinity. When you do know a number, we can use bracket if it exists in the graph. But infinity, do you know why infinity is in the graph? We don't. Giselle. When you go from negative infinity, how come you don't stop at 5 and then want to go? You stop when you have a hole. Do you have any hole anywhere in the graph? It's not a hole, it's a close. Eric. Bracket means the y value is there in the graph. So when we have y3, we do have a y value there. It's a closed circle. Closed circle means y value exists. Open circle, like something here, it means that spot is empty. You don't have any x value for that spot, and you don't have any y value for that spot. So when you don't have any hole, every time it's continuous. And for continuous, it's bracket for a number, and for infinity, it's parentheses. We also have a question. I saw your hand. Question? No? So are you guys confident with your domain and range?
I have a question. Unless the line is actually packed include a number as when we're to a close bracket, like if that line, the red line was patched include 5 itself, it would have been.
True. As long as you have a number in one side somewhere for that x value or that y value, the number exists. So now we have 2 more. A hint, our domain and range can be one number or can be interval of numbers. So what's the domain and range for a vertical line and a horizontal line? Think about it. Danielle, no fun. Ready? Okay. Domain and range. Who thinks definitely he or she got the wrong answer for domain? So you think your answer is wrong for domain? Tell me your answer. Negative infinity to positive infinity. Who would like to tell me whether she is correct or she is wrong? Remember, domain is x value. It's not infinity. So what's the domain? 8. See, it cannot be infinity. Do you have x value here for the function? Do you have any x value here for the function? Here. Do you have any x value here? So what is x value you see in the function? Only 8, right? From the x-axis, there's only one number we use in our function. That's the number 8. So you are correct, you are wrong. The answer is 8. And when you have a single number, we use something called curly bracket. It's like something like this, curly bracket. For one number is curly bracket. For two numbers, so it's parentheses and bracket. Okay? So who thinks they got range wrong for sure? Any brave person like Madison? She only tried one. She was brave enough to admit her mistake. Anyone else would like to try range? He thinks or she thinks the range is wrong. 0. Is she correct? Is our range is 0? Anyone would like to answer that? She is wrong. Great. Remember, y is the smallest y to largest y. Sorry, range is smallest y to largest y. So for y0, we have a function true, but for y -4, don't you have a point in the function? Do you have a y value there? What's the point here? X value is 8, y value is -4. Look at this point. At this point, what's the y value? So are we using all the y values? Because the line is going on forever and ever? Yeah. So we do have y value at every point of the line. Similarly, we do have y value every point on the upward. So we are using the y values. We did not use any x values besides 8, but we do have all the y values in our graph. So our range is negative infinity to positive infinity. So Kimel said, did you understand what we did? Look at all the y values. Look at every point on the line and see what's the y value you have. And keep observing your y values. For example, here, at this point, we have 8, -3. Then we have 8, -8, 8, -12. So we do have different y values for the same x value. That means we are using all the y values. We just didn't use the x values. Who would like to give me wrong answer for the next one, domain? Who thinks his answer is wrong? Brianna. I'm doing this in my head. When did it go 0? Okay, so domain is 0. Is she correct? Muhammad. Yes, Brian, it's not 0. So our x is here. We do have a point in the function when x is 0. True. But how about here? Don't you have any x value there? Don't you have any x value there? Don't you have any x value there? There. And the line is going on forever. So aren't we using all the x values from left side to the right side? So yep, the answer is not only 0, it's from negative infinity to positive infinity, everything. That line contains all the x values. Now range.
Can the answer ever be 0? Like,
Depends on the graph. So what's the range here? Negative 3 is here. Positive 3. Positive 3. So when we have a one number only, it's curly bracket because you're using one number. And when you have an interval, it's parentheses and brackets. Yes. I'm going to give probably 3. 3 of these in the exam. So Brianna, you asked me, can you ever have a 0? We can. Look at this example. Let's say our domain is 0. So if you want domain to be 0, that means you're using here. This is your graph. X equals 0. Let me use my yellow. This part. So this is x-axis. This is y-axis. And this point, the domain, we are using only one x value. What is this x value? 0. So domain here is 0. Domain. So based on the graph, we can have one number or we have a set of numbers. Any question on finding domain or domain and range from graphs? Is anybody who is confused? No? Okay. Now you're going to find domain and range from equations. You can ignore the second one. We're not going to the second one in this class. We are going to do polynomial, even root, and Gaussian. Three types of function you're going to work with, and you'll see what are the domain they have. So polynomial. Let me give you little details about polynomial. Polynomials are those functions, they have no variable is on the denominator. They don't have any power with negative or fraction. Okay. If you have an equation that doesn't have any negative power or fraction power, and none of the variable is in the denominator, then it's a polynomial. This is the definition I remember as far as I know. I don't have an example at the moment. Yeah. For example, y equals mx plus b. It's a polynomial because y and x, they both have power whole number, positive. Or y equal, let's say, x to the 100 plus 2x to the 5 minus 10. It's also a polynomial. Because if you observe all the variables, they have positive whole numbers and none of the variables are at the bottom. So these are examples of the polynomial. Now, if you're working with polynomial, polynomials are those equations which doesn't have, polynomials are those functions which doesn't have any negative power or fraction power, and none of the variables are the denominator. Examples, a line. A line is a polynomial. This one is a polynomial. Or we have more examples. Let's say y equals 2x squared plus 5x plus 1. This is also a polynomial. Why? Because all the x, they have whole numbers, whole positive numbers as their powers. And none of the x and y are in the denominator. So no negative power, no fraction power, no variable in the denominator. If you have them, it's a polynomial. Now in a polynomial, we can substitute our x, all these x, with any number. We don't have a problem. When we substitute x with anything, we get something back, some real numbers back. And remember, domain is what numbers you can plug in your x-axis. Sorry, in your x, in the function. So you can substitute x with anything. So our domain is from negative infinity to positive infinity. We can plug in any number for our x. So polynomial has no problem. They're smooth function. We can plug in anything in a polynomial. Now then our problem starts when you go to the second type of function. In the second type of function, we have an even root function. And whenever you're dealing with even root, we bump into some problems. For example, here, even root of 4, even root of 0, and even root of -1. Do you know what is even root of 4? Like square root of 4? Square root of 4 is 2. Do you know what is square root of 0? It is 0. What does square root mean? Square root means find a number. When you multiply the same number twice, it becomes the thing you have inside the square root. So that's why square root of 4 is 2, because 2 times 2 gives us 4. And square root of 0 is 0, because 0 times 0 is 0. How about square root of -1? Can you think of a number, multiply the same number twice, and it becomes -1? Can you think of any number? So this thing doesn't exist in real life. It does exist in the imaginary world, but in the real world, it doesn't exist. Even. You can write undefined. So the concept here is whenever you're working with even root, we bump into a problem when you have a negative inside. We can never have a negative inside in the even root. That's why when you work with the function, we have to see the function we have inside the square root. Where this function is positive, where this function is negative. Wherever it's negative, we cannot have that in the domain. Okay? So you only look at where this function is 0 and where this function is positive. Only that on that interval, whatever numbers we have, we take that in our domain. For example, let's see here y equals square root of x. Simple one. Can you substitute x with any number in this function? Can you substitute x with -1 here? Can you substitute x with -1/2 here? Can you substitute -1/3 here? So what is the smallest number we can substitute our x with? 2. Can't you do anything smaller than 2? 1, 0. The smallest number we can plug in here is 0, because square root of 0 is 0, which is a real number. So our domain for this function is the smallest number 0, and then can you plug in everything after 0? Like any number bigger than 0, can you plug in here? We can. We may not know the answer directly, but we can plug in. For example, 2. When x is 2 is square root of 2. Isn't square root of 2 a real number? It is, right? Can you plug in x with 3? We do have square root of 3. We just don't know how much is that. But we still can plug in x with anything bigger than 0. So what is the largest number we can plug in for our x here? Infinity. We can plug in anything bigger than 0. Infinity is a symbol, so we put parentheses. And since we can plug in 0 and get a valid number 0, so 0 gets bracket. Since we can plug in x with 0, and square root of 0 is a real number, so 0 gets a bracket. If you plug in and get a real number, it's bracket. If you plug in, if you don't get a real number, it's parentheses. So see, this function has a problem. It only runs from 0 to infinity. Now, we would like to know about the domain for any type of even root function. For example, y equals, let's say, x plus 5. What is the smallest number you can plug in that function for x? 0, okay? If you plug in 0, you get 0 plus 5, square root of 5, 2. But can't you plug in anything smaller than 0? How about negative 1? When x is negative 1, we have negative 1 plus 5. What is negative 1 plus 5? 4. And what is square root of 4? Real number, right? So yes, you can plug in negative 1. Can you plug in anything smaller than negative 1? How about negative 2? Yeah. Negative 2 plus 5 is positive 3. We can plug in. So what is the smallest number we can plug in? Negative 5. Negative 5. So we cannot plug in anything smaller than negative 5. We have to plug in the smallest number, negative 5, and we can plug in everything bigger than that. So our domain is negative 5 to infinity. But how did you come up with negative 5? How did you come up with negative 5?
But you're saying that it has to be the smallest number. So 0 can't be the smallest number because there's 5 in the equation. So it would have to be less than that. Like, it would have to be the opposite.
True. Opposite. So how do we figure that out is this. We take whatever we have inside, whatever function you have inside, we take that function, x plus 5, and we say, well, this function can be bigger than 0, or it can be equal 0. So that function can be 0 or positive, and then solve for x there. See what makes the smallest x, what is the smallest x value you can plug in here that satisfies this condition? So we subtract 5 from both sides, and we see our x has to be definitely bigger than 5 or equals to 5. And this is what we have here. Start your x value from negative 5 and plug in everything bigger than negative 5. So the solving process is whatever you have inside your radical, set it bigger than or equal 0 and solve for your variable. Okay? So our second type of problem, we know how to deal with. Now comes the third type of problem. Third type of question or second type of problem. A rational function. Something like this, 1 over x. Can you substitute x with any number here? And we get something valid back. For example, let's substitute x with negative 5. Point x is negative 5. What's the outcome we have? 1 over negative 5, right? Is 1 over negative have a real number or not a real number? Real number. Real. Think about number line. We have 0 here and negative infinity, positive infinity here. Can you spot negative 1 over 5 in this number line? We can, right? It's somewhere on the negative side. So it does exist. Can you plug in x with negative million? So we have -1/1,000,000. Can you plot it somewhere in the number line? We can, right? It will be somewhere on the negative side. Can you plug in x with let's say 1,000? So we have 1/1,000. Is it a real number? Yes, because we have it somewhere here. We don't know, however, it does exist there. Now, is there any number that you cannot plug in here? Because the outcome will be something doesn't exist. Can you think of anything that we cannot substitute our x with? You actually seen this many times in your life. Yvette. -5 does exist.
No, actually. Like,
-6. 1/-6. Don't you have 1/-6 in the number line? I do. If it is symbols, we don't worry about that. I'm talking about numbers. 0. Why? What's wrong with 0?
You had said if you have 1 million better than 0, you have 1, right? Or is it 0? I can't remember.
It says when you have $1, split your $1 into 0. Can you do that?
No.
No. Can you plot somewhere in your year 1/0? We don't know what is 1/0 because it's not possible. When I have 1 pen, I already have something. How can I ever split it into 0 pieces? I can split it into half, 1/3, 1/1,000,000. I can split it into a number, but 0 pieces, not possible. So there's only one number we definitely don't want to ever have on the denominator is 0. So the domain of this function is everything on the left and everything on the right on the number line, except for 0. Okay? Now the same concept goes for another function. Let's say you have a function 1/x minus 5. Now, can you plug in x with 0 here? 0 minus 5, which is -5, and 1/-5. Is this a real number?
Yeah.
Yes, somewhere here. So this time we can plug in x with 0. But what we cannot plug in here? 5. If you plug in 5, 5 minus 5 is 0, and 1/0 doesn't exist.
You can put in.
Right. So what we do is we say whatever we have on the denominator, it doesn't matter it's one number, one variable, or many things. Whatever we have on the denominator, that denominator definitely cannot give us the outcome 0. And now from there, solve for x and see what makes the outcome 0. Okay? Any question?
There can be any other number except the number itself.
Any number that makes the 0, not itself. So this is a simple one. But how about I'm giving you this one, something like this, 1/2x minus 5. Now what? See, you can plug in 5 here. 2 times 5 is 10, 10 minus 5 is 5, 1/5 is a real number. So what number we cannot plug in there? 2 and what? 2.5. 2.5. Yeah. How did you figure that out? See how smart he is? He multiplied 2 with something that will give us 5, and 5 minus 5 is 0. So instead of doing it mentally, what we do is we take this and we said, well, this thing cannot be 0, the result. So we solve for x. When we solve for x, first thing we do is we add 5 to both sides, and then we divide by 2, right? So what do you get? X cannot be 5/2, which is 2.5. So x can be everything else besides that number. Now let's do some examples. 3 examples only. Okay. First one, second one, And then the third. Figure out if they have any problem. If they do, how can you solve this? The first one, does it have a problem? Like, is there any number that you cannot plug in that will make the y value undefined? Negative 3 times negative 3 is positive 9. 9 plus 5 is 14. It is a real number. What type of function is this, the first one? Y equals mx plus b. So it's a polynomial. Does polynomial have any problem? It doesn't matter what type of polynomial you have. Any polynomial, none of the polynomial have any problem. Because they're polynomial. They don't have negative power. They don't have fraction power. They don't have any variable on the denominator. So what can cause them a problem? Nothing. It's like unmarried people. They're unmarried. They don't have any problem. Once you get married, you have your spouse, you have your children, you have your in-laws, you have your relatives, like so many problems, right? The polynomial is like unmarried one. Nothing, no problem, they're free. So they can use any x value for their x. Question yet? So what's the domain for the first one? They don't have any problems. So can you plug in any number for x? So if you plug in any number for x, what's the domain? Infinity. Negative infinity to positive infinity, because this is a polynomial. Yeah, we have that. What type of function is the second one? The type, the name, rational. So this is rational. Rational means they have a denominator. So what type of problem we face when you have a denominator? Denominator cannot negative. So what we do, we start with the denominator. We take it and say, our problem is denominator cannot be 0. Now, what do we have on the denominator? X plus 8. That means this thing cannot be 0. And now solve for x. So x cannot be negative 8. Because you subtract 8 from both sides, we get negative 8. So we can substitute x with anything before negative 8, anything after negative 8, but only negative 8 gives us a problem, something invalid. Let me visualize this for you. In the number line, you have negative infinity, positive infinity. We can take anything from the number line, but when it comes to negative 8, let's say negative 8 is here, we cannot use that negative 8. So something here, something there, everything is possible, but not negative 8. And now I would like to convert this visualization into interval notation. So in the left interval, what is the smallest number you see till what's the largest number you see? Brianna. Negative infinity, the smallest one. And the largest number you see in that left interval is negative 8. But we cannot use negative 8. So what do you use? Parentheses or bracket? Bracket means you're allowed to use it. Parentheses. Anytime you cannot use something, it's parentheses. Why you cannot use it? Because if you use it, you get a whole. And remember, whole and parentheses, they look similar.
What is it you convert into? What is it called?
Interval notation. Let me write this here. Interval notation. Okay, so this was our first interval, and then U means plus the next interval. Because we don't know what is the closest number to -8. What makes the denominator 0? We cannot have denominator to be 0. So what makes the denominator 0? 8 plus 8 is 16. Negative. So it cannot take -8 because -8 makes the denominator 0. And if you're not using -8, why are you including it? Well, because we don't know what is the closest number to -8. So we go up to -8, but we are indicating we're telling others that, hey, go to -8, but don't use -8. How about the second interval? How can you write the second interval into interval notation? In the second interval, what is the smallest one? Good, -8. Go ahead. So U means or plus. Okay, this is what it means. And this one means and. It's something like, why are you have two things intersecting? That's the and. And U means you're combining the two intervals. You're combining with plus, like this plus that is U. And intersection means this and that, they have this portion in common. So interval notation, when you express domain and range, we never use intersection, we always use U. Union means plus. So the first interval plus the second interval. This is what it means. So in the exam, you have to write this interval notation. Same thing like this one. This is interval notation. Okay, now comes the last problem. What type of problem we face when you deal with even root, like square root? What we cannot have inside the square root? Negative outcome. So in here, what we do have right now is this thing, 2x plus 1. So we said the function, whatever that is, inside the radical, that function, this function must be bigger than 0, or it can be equal 0. Because square root of 0 is 0, it does exist, and square root of something positive does exist. Okay? So that thing we have inside the square root, that thing has to be bigger than 0, means plus, or can be equal 0, means 0. So what thing we have inside the square root? 2x plus 1. That thing, whatever that is, has to be bigger than 0, or it can be equal 0. And now from there, solve for x. That will tell us individually from what x value we are allowed to plug in our numbers. So you're going to get the epsilon. What do you get rid of first? Do you divide divide by 2 first, or do you get it the 1 first? 1. Remember in the first day of class I said, if you want to get rid of something from anything, you have to start from the farthest distance. You take out one after another and then get close to that thing. So you subtract 1 from both sides. We get 2x bigger than or equal -1. And now what do you have to do to get the x alone? Divide by 2. So this is telling us that the smallest x value we are allowed to substitute our x with is -1. You can plug in x with anything starting from -1/2 and bigger than -1. So let's say our -1/2 is somewhere here in the number line. And here's something bigger than that. They're telling us use -1/2. You can substitute x with -1/2. It will give you 0, and square root of 0 is a real number. And now you can substitute anything that is bigger than -1/2. So starting from 1/2, everything bigger than 1/2. Only these numbers you're allowed to substitute your x with. So how do we write this in interval notation? In this interval, what is the smallest number you see? -1/2. Can you use x with -1/2? Yes, because when x is -1/2, we get half of 2 is -1. -1 plus 1 gives us 0, and square root of 0 is a real number. Since we allowed to use -1/2, so -1/2, do you get bracket or parenthesis? Bracket. Bracket means we can use that number. See here, we could not use -8. That makes us inequality. So use parentheses. But here we can use the -1/2. Let me show you again. When x is -1/2, our y is 2 times -1/2 plus 1. 2 to cancel out at -1 plus 1, which is 0. And everything is under square root. Do you know what is square root of 0? 0. So see, we can plug in x with -1/2. And since we can, so it's bracket. And what is the largest number we can plug in for x? Infinity. And infinity always gets parentheses. It gives us a number. We don't know what is that.
So any infinity sign comes with a parenthesis.
Hmm.
Even if it's negative.
That's all about domain. For this class, when you go to pre-calculus, you'll see 6 types of question, 6 types of scenario, okay? And you're going to do 6 times of these 6 types of problems. In this class, we did only 3. Polynomial, it doesn't have any problem, like single person. And then we have rational, when you cannot have 0 on the denominator. And the third type, even root, when you cannot have a negative number inside the radical. Can you do what? Sure. Let's say we have example. Y equals square root of 5x plus 15. Now 15 is too easy. Let's say 17. 5x plus 17. So what types of number you can plug in here? Starting from which number until which number? 0, yes, you can plug in 0, no problem. But can't you plug in anything smaller than 0? -5 times 5 is -25. -25 plus 17. Are you going to get Negative 4. Negative 4 times 5 is negative 20. Negative 20 plus 17 is negative number. Doesn't exist. Negative 3. Negative 3 times 15, it is negative 15. Negative 15 plus 17 is 2. Yes, you can plug in negative 3. But you cannot plug in negative 4. You see, when x is negative 3, we have 5 times negative 3 plus 17, which is negative 15 plus 17, which is 2. Real number. But what happens when you have x equals 4? Negative 4. It's 5 times negative 4 plus 17. That's negative 20 plus 17. That's negative 3. Not real. All right. So see, it's between these two, but exactly which one? We don't have to do it mentally because we know what to do. Take this, whatever you have here. 5x plus 17. And think about the condition. What is the condition? This thing must be bigger than 0. Also, it can be equal 0. And now solve for x. How are you going to solve for x? Subtract 17. That gives us 5x is bigger than or equal to negative 17. And then divide by 5. So exactly starting from negative 17/5 and then bigger, we are allowed to substitute into the function. Anything smaller than that, we cannot substitute. So our domain starts from negative 17/5 because this is the smallest number we can substitute. And we can substitute anything bigger than that. Brianna. We are saying this result is still bigger than 0, right? Or equal to 0. That tells us that 5x is still bigger than negative 17. That tells us that x is to be definitely bigger than negative 17 over 5, right? So x has to be definitely bigger than negative 17 over 5, or it can be equal to negative 17 over 5. So what is the smallest number we have? Look at the number line. We have negative 17 over 5 here, and negative 4 here, negative 3 here, right? Because we know definitely it's between these two, because we already tested the 3 and 4. Now, we can use negative 17 over 5. 5 times negative 17 over 5 plus 17. 5 cancel, we get negative 17 plus 17, which is 0. And square root of 0 does exist. So we can use negative 17 over 5. But anything smaller than that, we cannot use. Let's think about negative 18 over 5. Negative 18 over 5 we cannot use, because if you do that, negative 18 over 5, we get 5 times negative 18 over 5 plus 17. So you get negative 18 plus 17, which is negative 1, doesn't exist. You see? We can only use from negative 17 over 5 till bigger. So our domain, why is domain? Negative 17 over 5 to infinity. Our starting point is negative 17 over 5. And we can use it because when you do use it, it gives us the result 0, and square root of 0 does exist. It's a real number. Okay? So, what will be in the exam from today's lecture? 3 of these, because we have 3 scenarios. And then, these are fun, right? Probably 3 of these. You're not doing any math here. So probably 3 of these and 3 of that. So next Friday. The exam will be next Friday. So on Tuesday, we are going to start chapter 4. I already did that with my morning class. If you want to take a look, you can watch the morning recording. And then we are going to do a review on Thursday. Your exam will be on Friday.
The pictures like before that,
Sure. Which one you want to take?
wasn't it like absolute value?
Oh, before.
Like what you guys started with today?
Mhm.
Can I get a picture? Oh.
Here. And also, I'm going to post the recording. So whatever you miss, you can watch the recording. Ah,
Yeah, she said she's posting them on YouTube or on Bryce. Yeah, on YouTube. No.
not CUNY fast. Okay, so what you can do is this: subscribe me, and then you'll see them.
I got you. I was subscribed.
Yeah. See, go to this channel,
Take a picture of it. Wow.
and our videos will be here under your class 1023, the first playlist.
I'm going to be teaching pre-com.
The next semester class, we actually don't know because every semester they give us the class schedule, give us at the end of the semester. So
Do you do pre-com?
yeah, I did it before. And unfortunately, my recording got deleted, so I don't have any recording from before.
So today,
Huh? No, like I had another YouTube